Hello learners, welcome again to our lesson. So we are still looking at Form 2 topic. This is the first topic of Form 2. It is the structure of the atom and the periodic table. Previously, we have looked at the structure of the atom and we looked at the periodic table. We also looked at the electron configuration. We also calculated the relative atomic mass. So now, in our lesson 4 today, we are going to look at the ion formation. So the formation of the ion, and we are starting by definition of the term ion. So what is an ion? So an ion is the charged particle formed when an atom gain or lose electrons. So atoms with electron configuration of 2:8, 2:8 are said to be stable. So they do not lose or gain electrons. So all other atoms without these electron configurations tend to gain the stability by either losing or gaining electrons. So they can either gain or lose electrons to form the electron configuration of either 2:8, or 2:8:8. Then here we are going to look at the types of ions. So one type of ion is known as cations. So what are cations? Cations are positively charged ions. These are ions with a positive charge. So for example, we are going to look at how the sodium forms its ion and how it forms its positive ion. So formation of sodium ion. So sodium has atomic number of 11. Its electron configuration is 2:8:1. So with that configuration, sodium can either lose one electron to gain the electron configuration of 2:8, or still sodium can gain 7 electrons to acquire the electron configuration of 2:8:8. So it can either gain 1 or it can either gain 7 or lose 1 electron to form the stable electron configuration. So, but we can see it is easier to lose 1 electron for sodium than to gain 7 electrons. So sodium will form its ion by losing 1 electron to form a configuration of 2:8. So the resulting sodium, or the resulting particle, will have only 10 electrons. Remember, it has lost 1 electron in the outermost energy level. So the remaining electrons are 10. So, but in the nucleus, we still have the 11 protons. We have not lost any proton. So the 11 protons in the nucleus remain. Therefore, for sodium, now there will be 11 positive protons and 10 negative electrons. So this gives a resulting particle, a net charge of positive 1. So this particle is what we call the sodium ion. So we can see from this diagram here, this is the structure of sodium atom. So it has 2 electrons in the first energy level, 8 in the second energy level, and 1 in the third energy level. So this 1 electron in the outermost energy level is what sodium is going to lose so that it can form its positive ion. So it loses this 1 electron, therefore the whole or the entire energy level will be lost, leaving now the ion of sodium with 2 energy levels, as we can see here. So in the first we have 2 electrons, and in the second energy level we shall have 8 electrons. Then the lost electron, we indicate it up here to show that it is a positive ion since it has lost one electron. So that positive sign there is to show the lost electron. So that is how the positive ion of sodium is formed. In our next slide, we are going to see the equation. So this is the equation where the sodium atom loses one electron to form the sodium ion. So this is sodium atom. To form it loses one electron. So we have one electron that is being lost here. This is how we write the symbol of an electron, E, and a negative there as the superscript. And then this is the sodium ion. Magnesium and aluminium can also lose electrons to form positively charged ions. So that is how positive ions are formed. So we have seen that positive ions are formed when the metals, so most metals lose electrons to form positively charged ions. The second type of ions, we call them anions. So these are the opposite of cations. So anions are negatively charged ions. For example, the formation of chlorine ion. If you look at the formation of chlorine ion, chlorine has an atomic number of 17. Its electronic configuration is 2:8:7. So from the electronic configuration, we can see that chlorine can form its ion by either gaining one electron to attain the configuration of 2:8:8 or losing the 7 electrons to attain the stable electron configuration of 2:8. So which one is easier? Is it to lose 7 electrons or to gain 1 electron? Definitely gaining 1 electron is simpler than losing 7 electrons. So since it requires less energy, it is easier for chlorine to gain 1 electron than to lose 7 electrons so that it can form its stable electron configuration. So the resulting particle will have 18 electrons while the nucleus will have 17 protons. Remember, it has gained 1 electron. They were 17, so now they become 18 electrons. But then in the nucleus, we still have 17 protons. So there will be 17 positive protons and 18 negative electrons. So this will give the resulting particle a net charge of -1. Therefore, the particle will have a charge of -1. So this particle formed is known as the chloride ion. So the chloride ion has a -1 charge. So that is how we form negatively charged ions by gaining electrons. So this is mainly for nonmetals. Nonmetals gain electrons so that they can form positively charged ions. So this is the structure of chlorine atom. We can see it has gained 1 electron. So in its outermost energy level, they were 7. So it gains 1 electron. Then this electron now is not represented by a cross. It is represented by a dot to differentiate it with other electrons that were there in that energy level. So now to make them 8 electrons in the third energy level. Then that electron that has been gained, it is indicated up here as a negative sign to show that the ion formed is negatively charged. Then we say that nonmetals gain electrons in the outermost energy levels to form negative ions. So we have seen that. And negative ions, we have called them anions. Electrons in the outermost energy levels are called valence electrons. This is because they can be used to predict the valency. So the outermost energy level, the electrons that are in the outermost energy levels can be used to determine what the valency of that electron will be. So what is valence? Valency, this is the number of electrons an atom can lose or gain during a chemical reaction. So valency is also called the combining power of an element. Then some elements have variable valencies. For example, iron can have a valency of 2. It can also have a valency of 3. Copper can have two valences, a valency of 1 or a valency of 2. And also lead can have a valency of 2 or 4. So those are valences. Then we are going now to look at radicals. What are radicals? Radicals, these are group of atoms with a net charge that reacts and exists as a whole unit during a chemical reaction. So these are group of atoms combined. So two or more atoms are combined to form a radical. Then they have a net charge that reacts and exist as a whole unit during a chemical reaction. Examples of radicals, we have sulfate. This is sulfate ion. You can see it's SO4 with a charge of 2 negative, nitrate ion, ammonium ion, hydroxide ion, carbonate ion, and phosphate ions. So those are examples of radicals. So they are group of atoms. For example, you can see for the ammonium ion, it is a combination of two atoms, that is nitrogen and 4 hydrogen atoms to make one unit. It react as one unit, not as two. So those are radicals. Then the valency of radicals is the same as the value of its charge. For example, if we have sulfate here, the charge of sulfate is 2 negative. So sulfate has a valency of 2. Again, for ammonium ion, you can see that it has a positive charge, a positive 1 charge. Therefore, its valency is 1. So that is how we check for the valency of radicals from their charge. So the charge of the radical is the same as its valency, but you can see there's no sign. So we ignore the sign. For example, the 2 negative. Now we are going to ignore that negative sign and only consider 2. So 2 will be the valency of the sulfate ions. For ammonium, it is positive 1, but the valency is 1. Then we are going to look at the oxidation number. What is an oxidation number? So the elements react by gaining or losing electrons. As we have seen earlier, they gain electrons or lose electrons either to become cations or anions. So when they lose or gain electrons, they are said to acquire new states. So this new state is often referred to as oxidation state or the oxidation number. So oxidation state is the state gained by an electron after losing or gaining electrons. The oxidation number of an element shows the number of electrons which have been removed or added to get the present state. So the number of electrons that an element lose or gain to get the present state is what we are calling the oxidation number. Then there are positive and negative oxidation states. So it is either a positive or a negative oxidation number. And we say oxidation states are written with the positive or negative sign coming before the number. So this is the difference between oxidation number and the valence. We say that valence, we do not indicate the sign, but now for the oxidation number, the sign will come just before the number. So for example, if it was for sulfate, the oxidation number will be -2. So not just 2, but it will have the negative sign. So for example, we have +2, +3, we can have -1. So that is oxidation number. So that marks the end of our lesson 4. Let's meet in our next lesson. So in our lesson 5, we are going to look at the chemical equations and how we balance chemical equations. So we meet in our lesson 5. Bye bye.